So a normal distribution is given where the mean is unknown and the variance is 2 squared, that means 4. So now given probability of z is greater than 4 is equals to 30%. So find mu, find the mean. Okay, so we do the sum the same way we do it before. So probability of z is greater than 4 is equals to 30% means 30 divided by 100, so 0.3. So no, this is not z-score, this is x. Now we do the z-score. So z is greater than 4 minus mu, so divided by sigma, standard deviation is 2, so we can write divided by 2, so equals to 0.3. Remember, if you do z-score, the probability cannot change, the probability will always be the same. So now this is the case. Now what you have to do is you have to identify whether this thing is positive or not. So in this, it's always very helpful if you just draw a picture. So if you draw the picture of the standard normal distribution, because we have converted to z-score, so 30% means, and greater than means on the right hand side, and 30% means this is half, this is 50%. So let me show you. If this is the area, if the probability is the area, so if this is 0 for the standard normal distribution, this is the standard normal distribution, the mean is 0 and the variance is 1. So this region is 50%, 0.5, and this region is 0.5. So remember, if the probability is more than 50%, greater than 50%, so it is going to be on the positive side. But if it is less than 50%, it is going to be on the negative side. Remember, then the value of z would be negative. Maybe this would be plus a, this would be minus a or something. So this would be positive side, this would be negative side. So this is extremely important to know which side are we putting the value here. So greater than means on the right hand side, and 30%, 0.3 means definitely less than 0.5, so it will be somewhere around here. So this is 30%, 0.3, and this is positive a. So we can say let 4 minus mu, I hope you don't find this confusing, this is 4, this is mu, divided by 2 is equals to a. So therefore probability of z is greater than a equals to 0.3. Now we have, for this type of sum where the probability is given and we have to find the mean and the standard deviation, we have a special table called the percentage table, which is a greater than table. For this type of a sum, we don't have to look up the usual table. We can move on to the next table, which is a special table. Especially for this sum, it's the percentage table, and this table is greater than. So this will be, for this type of sum, it would be greater than. So now we are looking for the value of z. Z is greater than what? The probability is 0.3. So we have the probability as 0.3. The probability is 0.3. So we look up the probability here. So here, since we are doing the opposite, we know the probability. So if the probability is 0.3, then the value of z is going to be 0.5244. So that's it, we got it, we got the value of a. So that means, so 4 minus mu divided by 2 equals to 0.5244. Therefore from here we can find the mu. So this is going to be 4 minus mu equals to 2 into 0.5244, and this is going to be 1.0488. So 1.0488. So therefore mu equals to, if you send the mu to the other side and this to this side, it would be 4 minus 1.0488. So this would be 4 minus this answer. This would be 2.9512. So 2.9512. So depending on what the question asked, 9512, you can write the answer in 1 decimal places or 2 decimal places. So this is how the sum is done, and for this type of sum we use the other table if we can, which is a greater than table, percentage table.